Hi, and welcome to the digital job site, where the boards are straight, the weather's great, and there really is a board stretcher. In response to viewer interest in my Rafter math videos and blog post at finehomebuilding.com on the digital job site, gauged by the view count, and to address a comment on the Rafter topic from that video, I developed a three-part video and blog post series to explore hip roof framing a little deeper. And I titled the first of the three videos, Demystifying Hip Roof Framing with SketchUp, where I'll cover hip rafter geometry in general and explain the term dropping the hip in specific. Some of you might have heard that term. If you don't understand it, I'm going to try to explain it if you do. This is a way to visualize it or maybe clarify it a little bit. And to do this, I created the model you're looking at here, which is just a conventional framed hip roof. I drew this in a 7/12 pitch. I'll turn off the shadows as we explore here. And got Bryce standing by a set of sawhorses with components that are used for typical hip roof framing. In this instance, I've got common rafters, and then two sets of hip jack rafters, a left and a right, and then a hip rafter proper. Then all I did was make copies of the components that I drew to create the roof and just orbited them around and laid them on the sawhorses. But that's what a hip roof package, part of it, looks like anyways. So the important thing in my mind when talking about framing a hip roof is to make sure that the roof planes are flat and that they intersect in true straight lines. If you eyeball up the hip here from bottom to top, that's straight as an arrow. Each of the roof planes here are flat. Of course, this is a lot easier to do in the digital world at the digital job site than it is in real life, where rafters have crowns in them, and there's some variance there. But the idea is to strive for this flat roof without the hip being bowed up or bowed down anywhere along its length or at the overhang or at the or in between. So that's ultimately the goal of a well-framed hip roof, is to have flat intersecting roof planes that intersect in a straight line. And to peel back this onion a little bit, I set the model up with some layers, which I can get to with this layers dialog box. And I grouped this stuff in a couple different areas to be able to layer it on and layer it off and visualize some of the things I'm talking about here. So I'm going to hide the roof sheathing at the ends. You can see how that then opens up the roof. There's one common rafter in the middle, and then two sets of hip jack rafters, one on each side of this. And then the jack rafters are tied into the hip. And the plywood, I drew the plywood in the model with a 1/2 inch thickness to get the full effect. You can see how the bottom of the plywood is what's laying on the rafters. Let's see if I can orbit around underneath here. Bottom of the plywood's laying on the rafters, and it lays on one edge of the hip. If you zoom in here, you can see how the hip rafter is flat and the plywood supported right here by the edge of the hip rafter. So it's that edge of the hip that needs to be coplanar with the top surfaces of the common and jack rafters. That's getting into a little bit of detail there. But to go a little further into this, I'll hide the sheathing on the sides. And now you can see that the rafters, hide this dialog box, the rafters are all coplanar with each other, the top surface of the rafter and this corner of the hip. This will make, I'll try to explain that a little further to understand it. The same thing with the end of the roof. It's all in one plane. It all disappears at the same instant. You can tell it's flat. So that's a perfectly framed roof. Of course, these every piece here is precisely the same size. They're all straight as an arrow, unlike the lumber you'll get at the lumber yard. But this is what we're aiming for. And when you do math for calculating hips and jacks, they're all calculated on a straight line. And anyways, the next thing I want to do is show how the underside of the sheathing would look and how these hips ideally will support that those flat intersecting planes. So I'm just going to draw a rectangle here using the top of this fascia as a guide, and because I've grouped this geometry either by putting in a group or making it a component, I can select that rectangle that I just drew in there, and we can move it outside to work on it a little bit. You can see I'm moving it in the red axis there by the little dotted red line, and I'm just going to move it an even 55 feet. And when we slide it back, we'll just slide it over 55 feet. It'll go right back where we want it for this to demonstrate or to visualize what I'm trying to explain here. So if you look at a hip rafter or a hip roof from straight up above, you can see that the ridge and two pieces of fascia are parallel, and then the hips run at 45-degree angles, and that's assuming that the slope of the roof is the same all the way around, which I did in this case. Sometimes the hips are framed at a different angle for an architectural effect, but for purposes of this video they're all the same. I framed this up at a 7/12 pitch. So I'm going to use this surface over here to work on the explanation of what I'm going after here. So like I said, the hips all are oriented at a 45-degree angle from the sides and ends of the building. So I'm just going to draw these guidelines in with the protractor tool, and this will give you a little better idea how hip roof geometry is set up. So I've got those guidelines, and then by drawing some other lines in here, we'll create this piece of geometry for explanation purposes. So what I've done there is I've just traced those guidelines, and in essence, when you look at this flat plane and the roof itself, they look the same, looking straight down at them. And we'll want to pull this up into 3 dimensions. I'll show you how to do that. Slick little way to do it. First thing I'm going to do is create a guideline with the slope of the roof. I'm indexing this on the side of the building, bringing it to the midpoint of this line, which I know when it turns that blue circle, I'm just going to rotate a line up, and I'm going to put it at a 7/12 pitch by typing in 7:12, enter. That gives a 7/12 pitch guideline. And then I'm going to select this middle line and the move tool. When I do that, you can see Alt equals toggle auto fold down here. So I've got that line selected. I'm going to hold down Alt, Shift, and the up arrow key and grab this line by the center, which is a blue circle. And when I lift it up, I want to index it on that line. I guess I missed grabbing it exactly where I wanted to. There we go. Alt, Shift, up arrow, holding this at the middle. I just want to click it up till it intersects that line. And now by doing that, you can see I've created this hip roof plane structure, and this is ultimately what we're ending up with this hip roof framing. I hope this will all make sense as I develop this a bit more. So I'm going to group this geometry just to keep it all together, and then we're going to slide it back over by grabbing a corner, getting it going in the red direction, and then typing 55 feet, enter. Then if I did all that right, it looks like I must have missed something because these planes aren't lining up with the top of the roof like I wanted them to. So I've got to back this up. And I'm wondering if I got my guideline in at the right slope. So we're just going to go over here and double check. Starting it horizontal here in the green direction. There, it's trying to get to snap to green. I'm going to go 7, 12, Yep, so those rafters are in the right slope. I must have got something a little funny on this other side. So I'm going to go back through those steps, get this protractor to line up in the middle of the line, pivot it up, 7, 12. If I grab the move tool, I'm not going to get anywhere. Oh, there's part of my mistake. It jumped off that center point before I got the protractor going. Okay, this one's for the money. 7/12 pitch. Okay, now I'm going to grab this line, select the line, the move tool, Alt Shift up arrow, grab the line by the middle and pull it up to the line. And we've intersected the guideline. Okay. Sorry about double doing all these steps. It's just part of the SketchUp process. There's little technicalities. If you don't get them quite right, it'll let you know it. So I'm just going to slide this back over 55 feet. There we go. That's what I was trying for last time. Sorry about all the doing and redoing. But what you can see by the Z flashing here is that all the surfaces of the rafters are in the same plane as these flat surfaces of this little grouped geometry that we created here. And you'll notice that this line, or these two lines, are the corners of the hip rafter. If I go in and get in this group and then delete one of the faces, then you can see, come back out here, and something's behaving a little strangely there. I don't know why this whole thing isn't in one plane. Anyways, I'm going to delete those faces, and you can see how the actual planes hover above the ridge at the center and above the hip at the center. And so when you're creating a hip rafter, all the jacks and the edges of the hips and the edges of the ridge all have to be in the same plane. And that kind of demonstrates that a little bit. So I'm just going to select that group and hide it. We may want to look at it again in the future. But what I was trying to show there is when you're framing a hip rafter, typically you're using dimensional lumber, which has flat sides and it's not peaked the same way that the flat planes have to intersect. And so the hip rafter, the edge of the hip is going to meet at the edges of these common rafters. And one of the things that is confusing about the hip rafter is when you're installing it, sometimes you want to make this point line up with the top of the ridge. And if you do that, we go to View, Hidden Geometry, and unhide this group here, you can see that the hip rafter would stick up through the roof, or it would make the plywood bend up at the hips, so that hip is dropped. And the alternative to dropping the hip is to beveling the top of the hip. So if you would cut these little edges of wood off, bevel them to the center of the hip rafter, then you wouldn't have to drop it. But that's a lot of work to rip the top of those hips at an angle. So another way that I wanted to demonstrate this was to show you what a perfect hip rafter would look like. So I created that, a hip rafter. I'm going to hide these hip rafters, which are the ones that you typically cut, and then I'm going to open up a hip rafter with a beveled top. And so what I did was created hip rafters that have a little triangular bevel worked onto the top of them. You can see I put it here on the rafter, and if I go to edit this and move this little triangle up towards the top, you can see the function of dropping the hip. If you don't bevel the top of it, the hip sticks up too high. If you bevel the top, you can fit all these surfaces flush, but it's a lot simpler just to drop the hip and accomplish the same thing. If we go in now and view the hidden geometry and unhide this, I guess I should have put that as a layer also. Now you can see that these beveled surfaces of the hip rafter are Z-flashing as well, which mean they're in the same plane. What I didn't do is bevel and hip off the end of the ridge itself, otherwise those surfaces would be flashing as well. So can actually, maybe I'll just show this for anybody that hasn't worked with layers. I don't do it a lot, but they're pretty handy to have. So I'm just going to go up here to Window, Layers, hit the little plus sign. It gives me a dialog box, and I'm going to just call that Roof Planes. So that's the name of our new group there. Now by right-clicking that group, I'm just going to go here and then put this in the roof planes. Close that. And so now when I hide the roof planes, that disappears and it shows. This is quicker than going to hide and unhide if you plan on manipulating geometry like that. It's nice to have it set up this way. The other thing I did with this ideal hip rafter with the beveled top is I extended the tail at the end so that the surfaces come all the way down to the fascia. Go back in here and with the layers, go to roof planes. You can see how that rafter supports this roof plane. With 1/2-inch thick plywood, it's not necessary because it won't bend, but this shows you how the geometry is set up. And then if I take this hip rafter, move key, hit control, I'll move a copy of it out here in space, and then we can examine further what I did. This is what a very thorough, complete hip rafter would look like. It has this little, would have this little notch tail. Of course, this is it'd be senseless to go to all the trouble of cutting all these extra surfaces. They wouldn't do any good, but that's all part of the geometry of a hip rafter. The other thing about a hip rafter, which will show up in the other parts of the video, is a notch at the bottom here, which would fit around the corner of the building. I'll zoom in and show that in a little bit here. Got lost in my model, so I'm going to hit zoom extents. And then if we go back up to the top of the hip, you can see how in this bevel top hip, it's got this little extra piece of wood on there for the perfect hip. But you can see the amount of time it would take to bevel all these surfaces and make all the notches. It's kind of senseless to do all that. I'm going to show you one more thing on this rafter, and that is, if you look where the hip rafter intersects the wall, I'm going to try to zoom in here without making you too dizzy. But you can see how in a perfectly cut hip rafter it would fit to the sheathing on the corner of the building. Of course, when you're cutting a hip rafter, you just lop this off square, which shows up in, if I hide the hip rafters with the beveled tops and put the regular hip rafters in there. I guess I got these two little pieces of geometry. They need to be part of the other hip rafter. Shut off the hidden geometry. But this is typically how you'd cut a hip rafter, with just a bevel on the end for the fascia to meet, and then the bird's mouth is just cut out square. See if I can zoom in here. Sorry about all the Z flashing there, but you can just see how the typical rafter isn't framed to the precision. And when you're cutting, this surface normally gets cut back an extra quarter or half an inch just so you don't have to fight a little bump in the sheathing. But those are the things I wanted to show about hip rafters and their geometry, how these parts are all interrelated. And I hope that I've covered everything there about dropping the hip and those sorts of things. Maybe I'll do this one more time with the roof planes out of there. I'll show this layer. This is a conventionally cut hip rafter, and if we hide that and go back to the bevel rafter or the beveled hip, you can see how even at the jack rafters that little bevel fills in the space. And by editing this component, pulling that little triangle back, you can see how much work there would be by not dropping the hip if you chose to bevel things instead. But all these things come into play when we in the next video, when I show how I drew these components. You'll see how I work to make the heel height, which from the sheathing line, the hip rafter and the common rafters have to be the same height at the heel, which you can measure it at any point, but right at the outside of this wall sheathing, the height of the hip rafter from the top of that wall plate to the corner of the hip has to be the same. If I go and hide the bevel top hip rafters and put back in the regular hip rafters, you'll see that that line hits just the corner of the hip instead of following the bevel. So with that, I hope I haven't made you too dizzy with all the orbiting around, but I hope that explains some of the things about hip rafter geometry when I do the other videos and show how to draw these components. And then the third video will be how to use these drawings to measure and lay out for actually cutting rafters. And I hope that'll fill in some more information. So please check out this the blog post at finehomebuilding.com, which is the model and measure demystifying hip rafters in SketchUp. Check out that blog post at the digital job site. Hope this helps you learn things, and please feel free to comment if I've left blanks here, things that don't make sense, or if there's other questions you have about what I'm trying to show. Feel free to comment. I'll try to address those comments. In the meantime, thanks for watching and stopping by the digital job site and the Timber Tailors channel on YouTube.